Hello guys, this is Ishan Akbar. In this video, we'll discuss about the possibility of the profiles for gradually varied flow. That how many types of profiles can be made or can be observed for a GVF or gradually varied flow in hydraulics engineering or in open channels in hydraulics engineering. So basically, we have got five types of flow in open channels for the case of gradually varied flow. Five types of slopes means we can arrange a channel or our channel can have five types of arrangement depending upon the slope for GVF. For this, we will start with an example that our channel has no slope at all. It means that slope of the channel is equal to zero. So this arrangement of the channel geometry with zero slope is known as the horizontal arrangement, and it is denoted by H. The second possible arrangement is to provide a minor slope or a mild slope to the bed of the channel in a positive direction. Let us say this is the horizontal line and a positive slope is available between the horizontal line and the slope or sloping bed of the channel. So this category of the slope is known as the mild slope. This is denoted by M. And how can we identify these slopes, these profiles are this type of criteria? That is very simple. That let us say uh, this can be seen or observed by the geometry of the channel. If the bed is horizontal, then the slope or profile type will be horizontal profiles. But if the channel attains some slope and we are going to decide that which type of profile will be this one or which type of slope is this one, how can we decide that the slope is mild is simple. When we have a channel with a slope, it will surely have some amount of discharge and there will be a width of the channel. By this value, we will determine the discharge intensity by dividing discharge by the width of the channel. By using this discharge intensity, we will determine the critical depth of the flow. Let us say the channel is rectangular, then this will be the formula for the critical depth. So this is q square by g raised to power 1 by 3. When we have decided the critical depth of the channel, and we will determine the uniform flow depth of the channel. Uniform flow depth. And we will compare the depths of critical flow and uniform flow. If the critical flow depth YC is lesser as compared to the Y naught, then the slope of the channel will be mild. It is pre-decided that if the uniform flow depth is greater, we can say that if Y naught is greater than YC, then the slope of the channel will be considered as mild slope. And if the case becomes reverse, it means if we observe something like this, that Y naught has decreased and there is an increase in YC, it means with the increase in slope, when the slope becomes steep, then the velocity of flow becomes high. Velocity of flow increases, due to which the depth will decrease. It means that uniform flow depth will decrease. Normally, for YC, would draw a line, and this line is known as the CDL, critical depth line. And for uniform flow depth, we call it as, or we denote it by NDL. This is normal depth line. In case of mild slope, CDL will be at a lower level as compared to NDL, while in case of steep slope, this is third category of the profile or slope, that is steep, S shown by S. In this case, CDL becomes more as CDL, elevation of CDL becomes more as compared to elevation of NDL. So Y naught will be greater than YC in this case. Oh, sorry, Y naught will be less than YC in this case. Then we will be able to decide that the profile type is a steep type profile. And keep in mind that YC is equal to critical depth, which is determined by the discharge, and Y naught is the uniform flow depth in a channel. And when we say the flow is gradually varied, then we simply define it as steady non-uniform flow. That at single section, the variation in the flow parameters will be negligible, but with the distance, with the horizontal distance, or with the along the length of a channel, there will be a variation in velocity and depth of the channel. So on that base, due to variation along the length of the channel, that flow will become non-uniform because there is a change in flow parameters with respect to length, with respect to distance, but there is no change with respect to time at a single section. So this flow will be known as the steady non-uniform flow. So for steady non-uniform flow, we have another depth, non-uniform depth or non-uniform flow depth, which is equal to y. So to decide the main category, you have to compare YC and Y naught. In case of horizontal slope, we don't have Y naught because there will be no flow, or you can say the flow choking of the flow will occur, that there will be no flow. We can only determine the value of YC for this case. So we have only CDL, critical depth line. We don't have Y naught or uniform flow depth because there will be no flow in the case of S naught equal to 0 for a horizontal channel. Next step is mild slope. We will have both lines. There will be CDL and there will be NDL, but NDL will be above the CDL. And in case of steep slope, as slope, there is a simple concept behind this, that for steep slope, y naught comes down to the as compared to the YC. So for steep slope, what happens? Velocity increases. And what happens when velocity increases? The depth decreases. It simply means that for increased velocity and decreased depth, we have a Froude number of greater than 1. It means that for steep slope profile, the flow will be supercritical. And for mild slope, as y decreases, y increases, as y naught is greater than, y increases and v decreases. So the Froude number will be less than 1 and flow will be subcritical. It means that mild slope channel or channel with a mild slope will have a subcritical flow with a depth, normal uniform flow depth greater than critical depth, and in case of steep slope there will be a supercritical flow with critical depth more than the uniform flow depth. the, this is first case, this is second, and this is third case. The fourth case will be critical depth, critical slope. It will be between subcritical and supercritical. It means it will be greater than mild, but it will be less than. You can say that critical slope is less than steep slope, but it is greater than mild slope. So for critical portion, we have y naught equal to yc. For critical flow, the depth of flow becomes equal to critical depth. It means that both the lines are at the same level. NDL and CDL at the same level. Normal depth line and CDL touches each other. And at fifth position, so in this case, it means we will have velocity of flow equal to critical velocity and the depth will be equal to critical depth, why not? Uniform flow depth. At fifth number, we have another type of slope which is known as the negative slope. Here you can see that the slope is negative. Here the slope was positive, the slope is positive here, the slope is also positive here. Greater than the mild but less than the steep slope. Here the slope becomes negative. This type of profile or this type of arrangement is known as the adverse slope, and this is denoted by A. In this case, again the scenario will be same, that there will be no normal depth flow, means we will only have CDL because discharge is not possible as per the Manning's equation. A over n r raised to power 2 by 3 s square root. When s becomes negative, the square root can never be solved. It means that q cannot be, so flow will be not be uniform, or you can say that uniform flow is not possible. So in this case, we will not have y naught. We will only have yc. In this case, in case of horizontal, we will also have yc. In this case, in these three cases, in case of mild slope, in case of steep slope, and in case of critical slope, we will have flow. It means that mild, steep, and C have uniform flow in them, but in case of horizontal and adverse slope, there is no uniform flow. So if we summarize this from mild, steep, critical, horizontal, and adverse, what will happen for mild slope? What is the condition? Y naught is greater than Yc. Why? Y naught is greater than Yc because the slope is mild, the flow will move with lower velocity. And automatically, if velocity is less than Vc, then the depth will automatically be greater than Yc. In steep slope case, the case becomes reverse as of mild slope. V naught becomes greater than Vc, but Y naught becomes less than Yc. So what will happen? Froude number will be greater than 1, but in this case, Froude number will be less than 1. So for less than 1, flow will be subcritical, and for this case, flow will be supercritical. For critical slope, we have velocity equal to Vc, depth equal to Yc. So Froude number will be equal to 1, and the flow will be uniform with the critical depth. In horizontal case, there will be no flow. It means that there is no y naught. So we have only yc and no possibility of calculation of Froude number. It means that we can say that no uniform flow will occur in the channel. And again, in the case of adverse slope, there will be no y naught. We will only have a line of yc, means only cdl. And yc, for this condition as well, no uniform flow occurs in the channel. So this is the basic background of the flow profiles or flow types in a rectangular channel. So these are basically five basic types of profiles of channels, and again, and then we have three types of depths in the channel: YC, that is critical depth; Y naught, that is uniform flow depth; and Y non-uniform flow depth. Non-uniform, uniform flow depth, and critical flow depth. So this profile, so let us move at this page, and we can see for a mild slope, we have three lines. This is the bed line, this is the critical depth line, CDL, and this is NDL. We have basically three regions. One is above this line, this is known as region 1. One is between NDL and CDL, this is region 2. And second one is between bed and the upper first line above the bed, that is region number 3. It means for mild slope, we have three regions. It means that for mild slope, we will have three categories of profiles: M1, M2, M1 in this region, M2 in this region, and M3 in this region. And for the steep slope, if we draw the steep slope for a channel, so what will happen? There will be a simple change. For steep slope, what will happen? This NDL will be shifted and CDL will be shifted upward because critical depth increases as compared to normal depth. So we can simply say that the region above this top line is region 1, between CDL and NDL is the region 2, and between upper line or first line and the bed is region number 3. It means that we will have three profiles for the steep slope as well because there are three regions. So further types or subtypes of the profiles depends upon the number of regions for a specific slope. If we move towards the critical slope, what will happen, as we saw in this figure, that for critical we only have one line, that is NDL and CDR overlap each other. So we can simply say that this is the critical slope C, and we have a single line which shows both NDL, normal depth line, and critical depth line. So it means that we have YC equal to Y naught. Here we have Y naught here, YC here. In this case, we have YC, and here we have Y naught, normal depth line. In this case, we only have two sections, one above this line and one below this line, between bed and the upper line. If we see in these two cases, for mild and steep case, between NDL and CDN there is region 2. But in this case, here see, in between CDL and NDL the region is numbered as 2. But in this case there is no region 2 because NDL and CDL has become the same, has overlapped each other. It means that there will be no region 2. The region 1 is there and region 3 is there, but region 2 will be missing as there is no gap between CDL and NDL. For fourth case, we have adverse slope. For adverse slope case or horizontal case, let us go with the horizontal. For horizontal case, we again have a CDL line because there is no NDL line. So for CDL line, only there are two possibilities from the first case. We have number 2 and number 3. Means there will be profile number 2 and there will be profile number 3. And for adverse slope or negative slope, we again will have a CDL line, there is no Y naught line, or there is no normal depth line because region above the normal depth is known as the first region, and there is no uh, normal depth line. So this will be again region 2 and region 3 for a negative slope. You can see the slope is negative here. So this is A. It means that H will be further divided into two profiles, H2 and H3, and here for adverse that will be divided in two cases, that is A2 and A3. But in critical case we will have two profiles, C1 and C3. So in total, we have 3 plus 3, 3 for mild, 3 for steep, 6, 6 and 6, 12 profiles. It means we can say that GVF can be classified based on 12 number of profiles. How can we deduce that the profile may be M1, M2 or M3? For this, we will need to compare these three depths. By comparing YC and Y naught, YC and Y naught, they will decide M, S, C, H, and A, main category of the profile. When YC and Y naught has decided the main category of the profile, then we'll compare YC, Y naught, and Y to check the subcategory. Either it is M1, M2, M3, S1, S2, S3, C1, C3, H2, H3, or A2, A3. These are the subcategories. These are subcategories and these are main categories of the profiles. So how can we decide that if we have decided from YC and let us say, for example, I say that Y naught is greater than YC, it means that slope is mild. Then how will we come to know that, or how will I come to know that this profile type is M1 or M2 or M3? And how can we decide? To decide this, we will need to compare these both depths with Y. That is non-uniform depth. This Y is non-uniform flow depth. So let us say divide this in three parts. At first instance, we found that M slope profile is M because Y naught is greater than YC. So whether we say it M1, M2, or M3, what are the conditions to call it as M2, M3, or M1? For this one, we will simply compare Y with this Y naught and YC. If Y naught is greater than YC, the profile is simply M. So deduce. We you just need to arrange the things. Just draw three circles and place greater signs here. Again, draw three circles in the next section and put greater signs here. Again, draw three circles in this section and put greater signs. Sorry. For M1 type, our Y, our non-uniform depth will be greater than Y naught and Y naught will be greater than YC. This condition is must because for M profile, we have Y naught always greater than YC. But for M1, Y will be greater than Y naught and YC. In next case, Y will be less than Y naught. Y naught is greater than Y, but both of them are greater than YC. At a third condition, Y naught is greater than YC and YC is again greater than Y. It means that we have to place Y in these places, in diagonal places. And we will shift YC from third place to second place at the last for the M3 profile. Means for first case, Y is greater than both Y naught and YC. In second case, Y is greater than Y naught, but Y is less than YC. Oh, sorry. Y is less than Y naught, but Y is greater than YC. For third, this is M1. And for M2, this is the case. And for M3, Y is less than Y naught, and again, Y naught, Y is less than also, Y is also less than YC. So these are the three conditions which will decide the type of profile for a flow, for gradually varied flow. If Y non-uniform flow depth is greater than Y naught and YC, remember the first condition that Y naught will be greater than YC for a mild slope. This is the first condition to be satisfied. Then we will compare the value. Let us say we have value of YC equal to 0.24, value of Y naught equal to 0.38, and Y equal to 0.31. So now we will compare, then we will first find out the type of slope, that which slope or which main type of profile it is. We will simply compare YC and Y naught. So what is the possibility? Y naught is 0.38 and YC is 0.24. We'll simply say that Y naught is 0.38. It is greater than YC, which is equal to 0.24. It means that Y naught is greater than YC. Y naught is greater than YC. So we can simply say that the slope is mild. So what is the possibility? What is the possibility that which it will be M1, M2, or M3? So in which type of flow profile it exists? So basically for this we will compare the value of Y naught and YC with the Y. Or you can simply compare Y and Y naught. So what is value of Y? 0.31. Y is equal to 0.31. It is less than Y naught because the value of Y naught is 0.38. But what is value of YC? 0.24. It is less than the value of y, 0.31. It means y is in between y naught and yc, because yc is less than y, but y naught is greater than y. It means this value comes in the middle. Means the arrangement of values is like this: 0.38 is greater than, 0.31 is, sorry, greater than, and this is greater than 0.24. When you have arranged the values, now just put their symbols. What is 0.38? It is y naught. What is 0.31? It is y. And what is 0.24? It is yc. Now yc becomes in the middle. So when y comes in the middle, so when y comes in the middle of y naught and yc, the case will be second one. So the profile for our question or for our values is M2 type. Again, for the steep slope, if y naught is less than yc, then the slope is steep slope. So what category will we follow? M1, S1, S2 or S3? It will again depend upon the values of y as compared to y naught and yc. So it will be S1, S2 or S3. It will be S1 if y is greater than yc. You just simply need to replace y naught and yc with each other. For mild slope, y naught is greater than yc, but for steep slope, yc is greater than y naught. So here is y naught, we will write yc. This is greater than y naught. Here it was yc, we have replaced it by y naught. In these all three relations, you have to replace y naught with yc and yc with y naught. So in this, we will write yc is greater than y, but it is greater than y naught. And again, for y naught, yc, it is greater than y naught, and it is greater than y. So these will be profiles like S1, S2, and S3. And in critical flow condition, we will simply check the possibility of our depth if it is greater than our non-uniform depth. In the same scenario, for critical slope, we have C1 and C3. For this, y naught will be equal to yc. If y is greater than y naught or yc, because both are same, so if y is greater than y naught, it means that it is greater than yc. This is clear. So it will be C3 profile like this one. And if we can see that y is greater than y naught or yc, and if y is less than y naught or yc, then the slope profile will be C3. And in the same case as for adverse and horizontal profiles, that will be if y is greater than yc, then the slope will be a2, and if y is less than yc, the profile will be a3. And for horizontal is y is greater than yc, the profile will be h2, and y is less than yc, the profile will be h3. So first of all, you have to decide the main category, either mild, steep, critical, adverse, or horizontal, and then you have to go towards the subcategory of the profiles, either M1, M2, M3, S1, S2, S3, C1, C3, A2, A3, or H2, or H3. Any of them, any of these 12 profiles may be possible in case of a gradually varied flow. So this is all about the profiles. Thank you very much. See you in the next video with an example of gradually varied flow.